live stream the meeting. I'll give you a countdown if you like.
Okay, then we'll start again, shall we? Let's go.
Okay, 3, 2, 1. I believe we are live. Take it away.
Good evening and welcome to Are You Smarter Than Undergrad? Tonight, for your entertainment, 5 academics from across the UK have agreed to be put in the hot seat to test their knowledge of physics. We were originally planning on having a celebrity host for this evening. However, unfortunately, I found out earlier this week the IOP will not pay Mr. Blobby's demands to release Noel Edmonds. So instead, you're going to be stuck with me. So we have 5 academics with us this evening, and I'd like to now invite them to introduce themselves and say a bit about themselves, or if they want, they can just say hi. They don't even need to say their name. You can all see their names, and maybe let's start off in alphabetical. Fran, please. You want to unmute and say hello to the audience that we have?
Hello, I'm Fran. I do theoretical particle physics at Durham.
Thank you. And George.
Hello, everyone. I'm George. I'm sort of laser optics is my field, and in particular something called optical coherence tomography, which is enable us to use light much like ultrasound, but give us some sharp images of tissue, and particularly the eye.
Next, James, you're next in alphabetical order. I can definitely do this.
Hi, I'm James. I spend my time either teaching physics at a humanities university or doing laser tattoo removal.
And running planks.
And running planks.
Nabil.
Hello, everyone. I'm Nabil. I'm also at Durham, and I work mostly on theoretical physics, so things like string theory and quantum theory, mostly.
And finally, we have Sam.
Yes, I'm Sam. At least I was last time I looked. Don't observe me too closely, or I might become someone else. I'm a theoretical condensed matter physics at the University of Kent, and I used to teach Anthony. That's
everyone here has taught me. James has taught me the ways of planks, and we're also grateful for you doing this tonight. So, in the interest of fairness, and to take into account any technical difficulties or anything that might happen, each round the panel will get to choose from the grid of physics questions. Ooh, we don't have a jazzy animation for that. And this way, each panelist is guaranteed to have the opportunity to answer 5 physics questions. If you get an answer wrong, it's open to anyone else on the panel to answer it and steal the points. As I told the panel earlier, we don't actually have a way of recording the points. So I've got a piece of pen and paper in front of me, and I'm going to be doing that. Unless Matt is going to surprise me and has made something fun and amazing. I'm going to guess not.
I'm afraid not, no.
The grid of 25 questions are split very, very roughly into classical mechanics, quantum physics, particle physics, condensed matter, and astrophysics. And generally, as you go down the grid, the questions are going to get a bit more difficult. So to decide who's going first, I have a D100 to roll, and I've got you all in alphabetical order, and then we'll just go in alphabetical order. So we'll see who's going first. We'll do it splits into 20s because there's 5 of you, and it's landed on 43 when that would be 1. So James, you're going first.
Oh God.
Fantastic. So we know James is going to go first, then we're going to go to Nabil, Sam, Fran, and George. Right. Why are you guys doing this? Well, I asked you, but the real reason why you're doing this, which I put in the original email, which you might have forgotten, is eternal glory. You're going to get a certificate. You're going to get a mug. Yep. And you're going to have the sanctioned right for all eternity to tell all your students that problems that you set aren't difficult, and they are trivial, and they can be done in an afternoon on the back of an envelope. You have permission from the whole Institute of Physics, from the whole student community to forever say that. You're going to have a certificate. We're making a degree certificate that says that. Yeah, you can. So forever. That's it. None of the questions here are particularly difficult or require computation, but you might want a pen and paper, a calculator. But I think the hardest thing is multiplying by 4 in this tonight. Yeah, and when we're roughly halfway through, we're gonna have a break and grab a drink. Yeah. So drinks. To everyone that's watching, I would highly suggest you can play a game along with our panelists. For every time they answer a question wrong, you might like to take a shot of something like this incredibly clear milk inside a glass bottle. It's up to you. The IFP does not sanction this, and neither does the University of Kent. However, I don't represent either of them, so I'm fine. Right. What else? One last thing, of course. Much like all quiz nights, there is to be no arguing with my decision or the answer that I have written down in front of me. But if you do have a complaint, you may submit it in writing to Professor Paul Hardacre, 37 Claredown Road, Islington, London, N1 9BU. So any of the panelists that have a complaint about one of the things, you can submit it to Paul Hardacre. Right, I think the next thing to say is, let's play Are You Smarter Than Undergrad? And I apologize for anyone with headphones in.
Are you smarter than undergrads? Do you remember what you taught? Professor, now we're back in undergrad. Are you smarter than you used to be? Are you smarter than undergrad? How many facts can your memory hold? Teacher, now it's time for class. And do you think you've got the brains to pass?
Thank you to our incredible technical team and singers that put that together. And I apologize that my voice is also in there. So, James, the board is up to you. Please choose a category and a number.
Right. Well, I am definitely not smarter than an undergrad. So I'm going to play to my strengths and condensed matter for 50.
Condensed matter for 50, please, Matthew. Yeah. What does the acronym LASER stand for?
Shit. I should know this.
You really?
Simulated emission of radiation.
What's the L?
Light assisted.
Oh, I'm afraid that's wrong. Does someone else from the panel want to? George, you got.
I wanted. It's probably the only one I'm going to get tonight, so sorry. It's light amplification by stimulated emission of radiation.
Correct. That's 50 points to George. Oh,
can I retire now? I can retire hurt.
Yeah. Oh no, that's not the order. F, G, right. So we're off to a brilliant start. Absolutely fantastic. Let's have our next question. Oh, look, we've even got glitchy animations. I know in the actual show they like remove the card and it goes away, but we couldn't figure out how to do that on PowerPoint. So we'll just mark it down on my sheet that it's gone.
Of it, don't worry.
Nabil, what would you like?
Okay, I'll try a quantum physics for 50.
Quantum physics for 50. Okay. State Heisenberg's uncertainty principle for both momentum and energy.
Okay. I think that for momentum, you want that the uncertainty in the momentum of a state, delta P, times the uncertainty in the position, delta X, is greater than H bar.
Yep.
Okay. And for energy, I think you want that the uncertainty in the energy and the uncertainty in the resolution of the time, delta T, is greater than H bar.
Fantastic. 50 points already.
All right, thank you.
Who we got next? Oh, it's Sam. Sam. I can't actually read what I've written here. That's better.
I'll give classical physics a go then for 50.
Classical for 50. Okay, this is a difficult one. There is a block at rest and a ball moving to the left with speed v. In which direction will the block have moved after the collision?
To the left.
Correct. 50 points.
Excellent.
Yeah, I promise you the next ones are a bit harder, but not more difficult. Fran, what would you like?
Okay, I'll go particle for 50.
Particle for 50. Okay, if you add up all the charges of the quarks in the standard model, and that's just the not their antiparticles, what value do you get?
Okay, I'm doing this on my bit of paper.
I'd just like to say this question was submitted by Emma, not me. So
I know who to blame. I think the answer is 1.
that is correct. Fantastic. I think have we got all the 50s out of the way now? No, I think there's one more. James, no, not James, George. Already on 50. You're in the lead already.
I'm left with. Well, can I go anywhere, right?
Yeah,
so
yeah,
I don't have to stay with astrophysics. Well, maybe there's a chance I might get this. Who knows? That'll be amazing. Can I have astrophysics for 50, please?
Astrophysics for 50. Okay. What is the alphanumerical designation given to a class of supernova used as standard candles?
Nope. I mean, it's not no, but no. I have no idea.
No idea. Anyone on the panel?
Yeah, I think I know this one. I think it's 1A.
1A is correct, Fran. And that's another 50 points, and that puts you in the lead. Fantastic. So now, essentially, we've gone into round 2. But please don't feel that you have to go 100, 100, 100, 100, 50, 150, and 250. You can mix it up and feel however risky you want. And James, in last place currently.
Let's see if we can do something about that. Then condensed matter for 150.
Condensed matter for 150. Okay.
Yeah.
Consider arsenic added as a donor impurity to silicon to form a semiconductor. This reduces the effective band gap. The semiconductor acts as a source of what charge carriers, and hence it is named what type of semiconductor?
So it reduces the band gap. So it's lower energy. Electron would drop down. I would say electrons, so negative, N.
Yep, 150, 100 points, 150 points. You're now in the lead.
Woo.
If members of the audience do want to unmute and woo, that would be quite fun, actually. But don't woo when I'm reading a question. Nabil, it's your turn.
Okay. Let me try classical for 100.
For 100. Okay. Consider two electrical charges, plus E and plus E. The electric force between them is F. The charges are brought to a distance that is half the distance they were previously at, and the new force between them is 8F. What has happened to the second electric charge, or the first electric charge? It doesn't really matter.
Okay, let me think about this. So I have two charges of plus E and plus E. The electric force is an inverse square law, so it should go like 1 over the distance squared. Now, it looks like you have the distance. So what should have happened is the force should have gone up by a factor of 4, I think. Yes, 2 squared is 4. And so the force should have been 4F. If it's 8F, I'm going to say that you double the second electric charge.
Yeah, fantastic. That's like the hardest calculation to do this in this entire thing.
It was very non-trivial, I think. Squaring 2 is yeah, stressful under these circumstances.
Sam, it's up to you. Where do you want to go next?
I'll go quantum for 150.
Quantum for 150, okay. Okay, Right. Imagine a group of physics students are going to play a game of musical chairs during their prees before a night out at insert the name of the trashiest local student club. However, they have all forgotten the rules of the game. To remind them, a student, let's call them Anthony, says, "You are all identical fermions and each chair represents a quantum state." The game then proceeds with ease. In this rather odd situation, the game of musical chairs is analogous to which quantum mechanical principle?
I have to think about this. I'm not sure I remember the rules of musical chairs, so I'm going to have to guess. Is it the Pauli exclusion principle?
Is that your final?
Yeah.
answer? Then you are correct. 150. Woo!
Excellent.
That one I thought I'd make topical to everyone around the UK. They can insert their local student club. It used to say venue on it, but I guess it's only applicable to two of the panelists here. Who's next? Fran, it's your chance.
Okay, I'll go astrophysics 150.
Astrophysics. Okay. Astrometry, direct imaging, radial velocity, transit, microlensing, and pulsar timing variations are all methods of detecting what? Might add all successful methods of detecting.
Exoplanets.
That is correct. 150 points. That puts you in the lead. Are we halfway through? I don't know. Who's next? George. And you started off so well, and then you took a sudden dip and.
What's left? Yeah, I went for the astrophysics question, which was a mistake. What's left in the 100 range?
In the 100 range, there's condensed matter, astrophysics. During the break, we'll put X's through the ones that we.
Okay. Can I have the condensed matter one, please, Anthony?
Condensed matter for 100. Okay.
Yeah.
The alignment of magnetic ions in an antiferromagnet follows what pattern?
Oh.
You can indicate this with your fingers if you like.
Up, down?
Yeah, I'll accept that very well. Yeah, 100 points for that. Matt, I'm relying that you've crossed out X's on your little sheet and you can tell me when we're about halfway.
I certainly have. I think we've got maybe 2 more questions.
2 more. In
or
that
one
case,
more.
James.
I'll have another count.
James currently tied in last.
Woohoo. That's where I expected to come. What's the lowest classical number you can give me?
That would be 150.
Let's do that.
Also, this is the last.
150 has never been accused of being the lowest classical number.
Anthony, this is the halfway through question.
Okay. All right. There was meant to be a diagram on screen. Anyway, it's there's 2 resistors with resistance R in parallel with a cell that has a current running through it, and the value of the current is I. What is the potential difference across the cell?
B equals IR.
Does it look like this?
So
Yeah. Oh, thanks, George.
2.
2?
Yeah.
No. Would anyone else like to?
I think it's IR over 2.
IR over 2 is correct, Emil. 150 points. And at the halfway point, that does put you in the lead. Closely followed by Fran, then Sam, then George, and James, tied for last.
To explain my answer, I just assumed I and R equaled 1.
Okay.
Well, there was no diagram, and my attempt was probably not very good.
So
Our students never learned to draw diagrams.
I don't know. Dr. Carr says we always had to draw diagrams. So we're at the halfway point now. It seems you left the board with very high valued questions at the end. So we'll have like a 5-minute break. I'm probably going to get another drink. I think that's the way the second half is going to go. And George is already there. And we'll resume when Matt tells us it's time to resume, I'm guessing. Matt's going to do some X's so we see where we're at. Yeah. This is the awkward silence for five
Would
minutes.
you like another playthrough of the theme tune when we resume as well?
I would like another playthrough of the theme tune when we resume.
I can set that up for you.
Yes. Maybe we should have some interlude music.
The theme from Ski Sunday.
Okay. Good one. I was just going to go with an hour-long elevator music session.
It's the next best thing, I think.
I think this is working.
True to your word.
Is this break an hour long then?
Yeah. I don't even know what the time is. Oh, we're doing bang on time for the schedule that I threw together. Yeah.
And this is going as well as I thought it would go.
Well, you're not actually last. Technically, you're in fourth. For everyone watching, I'd just like to let you know the exam has been marked.
That's the answer from my question, isn't it?
What? Oh, in the chat. There's a lot of messages in the chat.
The elevator music icon is the answer to the anti-ferromagnetic question.
Yes. Oh, you've done that question. Okay, it's just the heavy hitters remaining. James, it's going to be all worth it for that mug, but I think he's ready to be sent.
Perfect. I mean, it hasn't arrived yet.
Oh.
I've been trying to blend in with the PLANCKS t-shirt by wearing an IAPS one.
We've been asked, are there any honorable awards for most creative answers? Yeah, we'll call it the PLANCKS Award for a creative answer, like some of the creative answers we had in today's exam. Let's give you a sneak preview of one of them, such as... Nope. Such as the most banging tunes usually have more than one frequency. Was a genuine answer to today's exam. No, I don't think so. And you'll see more of these fun tidbits from the exam in tomorrow's follow-up show. Not as good as Are You Smarter Than Undergrad, but it's the funnest thing on Sunday. You can forget the CERN talk, Professor Al-Khalili's talk. What the real thing is, James and I present exam statistics. Yeah.
I believe we're ready to resume.
We're ready to resume. Fantastic. Okay, I'll stop sharing that and stop the elevator music. as we get ready for, oh, hang on. There we go. Right. Okay, good. When you are ready, Matt, and we'll have the theme again. Welcome back.
Are you smarter than undergrads? Do you remember what you taught? Professor, now we're back in undergrad. Are you smarter than you used to be? Are you smarter than undergrad? How many facts can your memory hold? Teacher, teacher, now it's time for class. And do you think you've got the brains to pass?
And just like magic, all the X's have appeared. Welcome back to Are You Smarter Than an Undergrad? We have 5 panelists. I'm doing this as if it's like an actual TV show, in case people thought I'd gone mad. We're doing this for no point really whatsoever, apart from a laugh and the chance to get a mug and eternal glory for one of our panelists here. No, Calvin, this is not actually a TV show, but it is an internet show. So, you know, I think that's the way most TV is going at the moment. Maybe we should make it a regular thing. Maybe we should make it an IOP thing. Yeah? Yeah, James? Yeah? No? Okay.
Only if I win.
If you win, okay. Okay, so it's not going to become an IOP thing. Who did we leave off? I think we finished off with Nabil. You were our last question. And that put you firmly in the lead. So we start off with Sam. You get to pick from the numbers and the categories.
Okay, can I go with quantum for 250 then?
Quantum for 250. Quantum for 250. Okay. Normalize the wave function of a plane wave in a box of length L, which has wave function of the form psi k of x is equal to ae to the I kx.
Would that be square root of 1 over L then?
Yes, it would be.
Excellent.
Hooray! So that's 250 points. I know I put that as the example question in this document that I sent over to you, but I was just wondering how many people actually read the document. That's why I included it in the
Oh, I did that in a lecture yesterday, don't worry.
Okay, Fran. What would you like?
Okay, I'll go particle 200.
Particle 200, okay.
Might regret this, we'll see.
I don't think that's the 200 one.
Okay, good. Well, that's a relief.
Okay, maybe there's, okay, it is now the 200 one.
Okay, let's just go for this then.
What device is being described here? It's an AC device. It has an electric field between hollow metal Ds. It has an orthogonal magnetic field, and the particle's path inside it spirals out due to acceleration.
Is that?
Yeah, I do not know. Cloud chamber?
No, unfortunately not. Would anyone like to?
I would like to fail to answer this question, please.
Okay.
I'm sure it's not right. I'd go with cyclotron. But...
Cyclotron is the correct answer.
Oh, really?
Yeah.
So you can have 200 points.
Goodness.
Congratulations. Yeah, it was the cyclotron. George, it's your turn.
Well, I might want to try condensed matter 200.
Okay, condensed matter 200. Okay. Superconductors exhibit the Meissner effect below a critical field. They also have a normal state above a critical field. One type of superconductor has an intermediate state called the vertex state. Vortex state, that should say. Vortex state or vertex state? Vortex state. Which type of superconductor is this?
I don't know, but I'll guess. And I'll probably guess wrong, but I'd say low temperature superconductor.
Unfortunately, that is not.
Sorry, high temperature superconductor.
No, I'm afraid that's.
Can I answer?
Can I?
If both, I don't know who went first there. Chat, decide who went first, Sam or James. James Greedo. Sam, it appears Sam has been is victorious there. Sam, you have the. You may
Well, who knows? Type 2, or as I call them, Bob.
Type 2 is correct. I don't know what Bob is, but
It's
James.
what I call type 2 superconductors. One has to have whimsy.
Are you also going to say type 2?
Let's say yes.
And that puts Sam squarely in the lead. Right. Who's next? James.
Again. Is quantum for 100 still available?
Yeah, I believe so. Quantum for 100, please. Which German mathematician gives her name to a theorem that relates a symmetry of a law of nature to a conserved quantity? You may just give her surname if you only know the surname.
I don't think I know any of the names.
I think Sam and Nabil have their hands up. Are you giving up, James? Do you want to guess?
Yeah, I can't think of any female German physicists, mathematicians. Go ahead.
Let's go, Nabil. I think you might have had your hand up there.
Emmy Noether.
That is correct. I presume, Sam, you were also going to say the same because you taught me
Yes.
that theorem.
She had a cameo in one of the questions at Isaac's party.
Yes.
Anyway.
Yeah, I added her in there, and then I decided, oh, I should write a question about her. Who are we up to now? Nabil, it's your turn.
Sorry, I've forgotten a bit which ones are available. Is classical for 250 still there?
Classical for 250 and 200 is there, yes.
Oh, okay. Let me try 250.
Okay. Consider a pipe of radius 10 meters. It has an unknown fluid passing through it with a density of 500 kilograms per meter cubed. It has a velocity of 100 meters per second and a viscosity of 50 Pascal seconds, which results in a Reynolds number of 1 × 10⁴. What type of flow is this fluid exhibiting?
Okay, so first of all, I regret going for the 250, but let me try anyway. So thankfully, you calculated the Reynolds number for me, and it looks to me like it's high. Now, I think that fluids flow in two kinds of ways. There's either a laminar flow and a turbulent flow. I believe the turbulent flow is at large Reynolds number. So I think this is going to be a turbulent flow.
That is correct. 250 points. Very well done. Yeah, I was tempted just to leave in all the numbers, but then that would just be horrific.
I confess, I started writing down all the numbers so I could multiply them together, but I was really relieved when I saw that you actually multiplied them together for me, because I definitely would have gotten that right.
I apologize that when I transferred this off LaTeX into PowerPoint, I couldn't be bothered to superscript all the things. Fantastic. So Sam, you're tied now at the moment with Nabil. What are you going to choose? There is classical for 200 available, quantum for 200 and 100 available, particle for 100, 200, 250, and condensed matter for 250, and astrophysics for 100, 200 and 250.
Or quantum for 200 then.
Quantum for 200. Okay. Observation of gravitationally induced quantum interference by neutron interferometry, also referred to as the cow experiment, gives us a reliable relationship from both theory and experiment of which two universal constants?
I'll go to Vinyl. One of them will be the gravitational constant, I'm assuming, big G. The other, neutron interferometry, the relationship. If it's interferometry, then probably H bar.
I will accept that. Planck's constant and the gravitational constant G. Yes, that is correct.
Anthony, this was also in the example you gave us.
I know.
I don't think I got these examples.
You didn't, and you've chosen the only two questions that were in the examples.
Okay.
Which is good. Right, quantum, there only remains, oh, none of them. No quantum left. And so, Fran, it's your turn.
Okay, can I go astrophysics 200?
Astrophysics for 200, okay. What is the definition of flux, and how is it related to the luminosity of a star?
This is not the sort of thing that I know. I once did a stand-up comedy show about how stupid units in astrophysics are, but it hasn't helped. Okay, so flux, I'm going to say, is the number of photons per second per centimeter squared. And how is it related to the luminosity? Is the luminosity the total number of photons per second that the entire star emits? So it's then not to do with the area of your telescope?
I will say yes to that.
Oh, good, because that was very vague.
Yes, that is fine. Yes, I accept that. As the total amount of energy that crosses an area per unit time, and you relate that, the luminosity is related to it by multiplying by the area. Yes, I will accept that.
Good.
So 200 points. George, are you going to try and bring it back?
Is there no? I'm trying to aim high and go down in flames probably. Is condensed matter still available at one of the higher ones?
There's 250 for condensed matter.
Okay, no, it's that or nothing. So can I have that, please?
You can. This question is about exchange interactions of magnetic ions. Direct exchange occurs when magnetic ions' charge distribution overlap. How does super exchange take place?
Is it super exchange? Well, I don't know. I'd have to guess here. I'd probably go with an overlap of a wave function.
No, unfortunately not. Would anyone like to buzz in? Sam?
Give it a go when they both overlap with a third guy in the middle.
That is correct, yes. When the non-overlapping charge distributions interact with an intermediate non-magnetic ion, that is correct. So you got 250 points there. I can do basic maths, I promise. And that brings us back around to James. James, the only ones left are astrophysics for 100, astrophysics for 250. Condensed matter is gone. There is particle physics for 250. Everyone seems to have left particle physics alone. 250. 150, 100, and there is nothing left in quantum, but there is 200 left in classical.
Okay, then let's go for a particle physics one. I'll do 150. Is that free? Did you say?
Yeah.
Let's go with that.
Name all the fundamental particles in the standard model in under 20 seconds. You may omit antiparticles. Hang on, I got to time you.
Bloody hell.
Are you ready?
No.
These are all the ones that I wrote on my list. No. Ready?
Okay.
Go.
Up, down, top, neutrinos, electron, neutrino, the others. Oh my God. You had to give me the time limit one.
Sorry, but the time's expended, James.
Yes.
Would anyone like to pass it?
Do they get a reduced time limit?
They get only 2 seconds.
Sure, they can have 15 seconds. I think Sam's got his hand up there. Sam, do you want to go? You got 15 seconds. Go.
Okay. Quarks, up, down, top, bottom, strange charm, leptons, electron, tau and muon, neutrinos, electron, tau and muon, and gauge bosons, photon, WZ, 8 gluons, and the Higgs boson.
Correct.
Yay.
Fantastic. And
Yes, that came up in one of my lectures a couple of days ago as well. I do too
They
many
have-
lectures.
Did you have to rattle them out in 20 seconds?
No, the students didn't give me a time limit. In fact, I preferred I didn't rattle them out in 20 seconds, as it turned out.
Sam, you're definitely in the lead at the moment. Nabil, can you claw it back? There is available two particle physics questions, 150 and 250. There is astrophysics for 100 and 250. I think that might be it. Oh no, and there's also classical physics for 200.
Let me give a classical for 200.
Okay, classical for 200. What is the gravitational force of a mass m inside a hollow spherical shell of radius r?
Okay, so if we have a hollow spherical shell, then this seems complicated because if you're inside, of course, this will act in weird ways. But you can do a Gauss's law thing on like around the spherical thing in the center, and you get 0 actually. So the gravitational force is 0.
That is absolutely correct. 200 points. If anyone, I got baited so hard there, says Calvin. If anyone was attending the international finals last time, that was part of one of the questions. Although I didn't give you any points if you just said Gauss's law. You had to derive it. Sam, it's your opportunity to secure your lead.
Can you remind me which questions are open?
The questions that are open are: there is particle for 250, for 150 and 250. There is astrophysics for 100 and 250.
And that's it.
That's it.
I'll go particle for 150 then.
Particle for 150.
I have that down as being taken, and we have particle for 100, but I could be wrong. So I'll go to 150 and we'll see.
Click 150.
Yes.
Okay.
Unless you want to do it again.
Click 100.
Okay, particle for 100 then.
Particle for 100 then.
Is that the same question twice?
It is the same question twice. That is my fault then. Right, here's your question. A Goldstone boson is produced when what type of symmetry is broken?
Don't get me started on this. You can't break a gauge symmetry. You're probably looking for the answer gauge symmetry. Goldstone boson is when, yes, I'm not the Higgs one. The Goldstone boson is when a continuous symmetry is broken.
Yes, I will accept that. So that's we're going to give it 100 points for that then, if that's what the last one was left. And now we have Fran. Fran, you have particle for 250, astro for 100, or astro for 250.
Okay, I'll do particle for 250.
Okay, particle for 250. Consider the theory in 12 dimensions. What is the mass dimension of the field phi?
12 dimensions, okay. So that means the dimension of the Lagrangian needs to be 12. So then I don't know necessarily. I could assume that M had mass dimension 1, but maybe that's a false friend.
No, you may assume mass is 1.
Okay.
Mass is 1. Yes, you may assume that. Yes.
Okay, so then phi star phi has mass dimension 10, so phi has mass dimension 5.
Correct. 250 points. Very well done. Excellent. So, George and James, you're going to have the last 2 questions. George, you go first. You've got astrophysics for 100 or astrophysics for 250.
Oh, I'll definitely choose 250. Sorry, James. I mean, you may.
No, take it. Take it. I won't be able to answer it.
Well, you might.
What is the 0 point of the magnitude system?
Oh, is it the magnitude of a distant star? 0 point. Well, I guess it's going to be a reference point. Is this is the 250 question? The 250 point question? Are you sure?
Yep.
But it's probably a one-word answer.
And that one word is.
Well, it's not a reference star, is it? It's a 0 point of light. It's something measurable.
No help in chat.
Shall we go with
Make a guess?
alpha?
No, unfortunately not. Does anyone want to stick their hand up from thing? Sam, you stuck your hand up.
Is it the sun?
No, unfortunately not. James?
I was going to say the sun as well.
Fran?
I can have a guess. Is it Proxima Centauri?
No, Nabil?
Okay, nope.
Because we're all guessing, I confess I don't really know what this is saying. But is it 1? Is that the 0 point?
No, it's the star Vega.
Vincent Vega of Pulp Fiction. Should have given us a clue of that.
Unfortunately, as no one on the panel got it right, I get 250 points for each of you that got it wrong. So I'm now on 5 times 250 points, whatever that is.
I think you have more points than I do currently.
That's
not
more than
hard.
any of us.
Okay, James, for the final question, which you have no option of what it is, for astrophysics for 100 points, which could put you tied in 4th place. The absolute magnitude is defined as the apparent magnitude measured from what distance from the source.
Absolute magnitude is its apparent magnitude. And this is an astrophysics question?
Yep.
So I'm just going to guess 1 AU.
No, unfortunately not. Does anyone want to stick their hand up and guess? Fran?
Is it the distance between Vega and the Earth?
Good guess.
No, I don't think so. Anyone like to guess?
Oh, I've got someone in the attendance venturing a guess.
Should we see if chat? I think chat's going to get it before any of our panelists. Chat? No, not 13 meters, but you're absolutely correct. It is 10 parsecs is what the absolute measure is. So chat has been also awarded 500 points.
Oh yeah, exactly. And that particular person who said it obviously is
yeah.
it's the glory.
Hang on, I need to calculate my score. Oh no. Well, anyway, let's see what the scores are. Matt, did you want to go back to the original page so that when it's all said and done, we can exit on a high? And actually, we were pretty good timing because we ended basically bang on time. Right, in last place, as they said they were when I said this about 2 months ago, is James. Congratulations, well done, James. You will still receive your mug.
I just want to point out that how much hope is that giving everyone when I was the one marking and writing some of the questions for the past few years. So
As long as it's consistent, it doesn't matter. Words to live by. In fourth place, or not fourth place, in the next place up is George with 350 points. Very well done. In the place after that is, I believe, Iona, who got it first with 500 points. So congratulations to Iona in chat, who managed to get something that none of our panelists got. And then, quite close, Fran, you came in next with 700 points. Nabil, you got 850 points. I didn't even break the top score with my 1,250 points because our winner, and forever will be able to say that this is a bad thing, really, to say that Dr. Carr can do this. But you have, with 1,300 points, won Are You Smarter Than an Undergrad, the first ever IOP IAPS Kent PLANCKS event. Yeah, so James got one more. I think everyone in chat seems to be rooting for James rather than anyone else. So really well done, everyone. Thank you all for participating in this rather odd event, shall we say. It's certainly a different thing to spend an hour on Saturday doing.
Thank you, Anthony, for putting it together.
Thank you, Anthony.
Thank you. This was really
top
fun.
quality questions.
Yeah, very fun.
I think next time I'll spend a bit more time searching for them, make them a bit more wacky, like the exam this year. So I think the last thing to do is
bring in elements of popular culture.
Elements of popular culture. Well, we had Kylie Minogue in our exam this year.
Oh, okay.
So real popular culture there. Now, the next thing to say is online socials are on Discord from 9 o'clock. So please join in on those. I believe there might be bingo going on. There is, of course, the event that everyone's been looking forward to, apart from Are You Smarter Than Undergrad, and apart from Anthony and James present exam statistics, which is Physicists versus Ender Dragon. That is going ahead. And whoever kills the Ender Dragon first will receive a £15 pizza voucher thingy, what's it? That is canon. So you can hold me to that. And there are events going on. There's bingo and Among Us and whatever you really want. As it is the Saturday, and you guys don't need to get up till 10:30 tomorrow for the first lecture, so there's plenty of time for a lie-in and another drink. Thank you again to all of our panelists. And Matt, if you'd like to play us out, and if anyone wants to sing along to the theme, please feel free to, or just leave if you want, or stand there in awkward silence. It's entirely up to you. Matt, when you're ready. And I hope to see all of you in the social events.
Are you smarter than undergrad? You remember what you taught. Professor, now we're back in undergrad. Are you smarter than you used to be? Are you smarter than undergrad? How many facts can your memory hold? Teacher, now it's time for class. And do you think you've got the brains to pass?
Hooray! Thank you all very much, and good night.
Thank you, Anthony.
Yes.
Thank you.
Thank you all for doing this. It was rather silly, and
No problem. That was hilarious.
Yeah, I genuinely had a great time, actually. So thank you. It was really fun.
Yeah,
You're really nice questions.
I'm glad the chat liked it quite a lot as well. I think I'll have to be a bit more original with my questions next time. Stop using so many past quiz questions.
They were good questions, I think.
Oh, thank you. Yeah, I had a load of other ones, but I decided to scrap them last minute because I didn't want to LaTeX them and then crop that and put it into the PowerPoint.
Fair enough.
So I think if everyone, well, Molly, there's nothing else going on now, is there? Apart from the Discord stuff.
No, just socials from 9 o'clock on Discord. So you have an hour to go and eat, relax, chill out, and then come play some games. And academics, feel free to come play games if you want. If you kill the Ender Dragon, you will get that voucher. Whoever does it, so feel free.
I can kill the Ender Dragon. I'm up.
No, not you, Anthony.
Okay.
We can't do it. The academics can.
The academic, fine, that's fine. I will actually, for anyone that is on the chat and hasn't got the Discord server link, I better put that in here.
Anthony, you can also stop the stream.
Oh, can I? Right.